This video is about pairs of angles. You can find this material in your text in section 2-4. Complementary angles are two angles whose measures sum to 90 degrees. Supplementary angles are two angles whose measures sum to 180 degrees. All linear pairs are supplementary. Let's think about that for a minute. Here's a line, so angle ABC and angle CBD are a linear pair. Because this linear pair by definition lies along this line, the measures of the two angles must add up to 180 degrees. So all linear pairs are supplementary, but are all supplementary angles linear pairs? Think about that for a minute. These angles are supplementary, but they're not a linear pair. Find the measure of a complement and a supplement of angle B. Here's an example problem for you. Two complementary angles are congruent. Find their measures. Okay, I like to start out by drawing a diagram. The word complementary tells me that the angles add up to 90 degrees. So although the two angles don't have to be adjacent, I'm going to make the two angles adjacent in my diagram, and I'm going to have them adding up to 90 degrees. I'm going to label them angle 1 and angle 2. So I've used the information that the two angles are complementary. Now, how do we use the information that the angles are congruent? Well, I can label my diagram with matching angle symbols here. Or I can write out the statement that they're congruent by saying that the measure of angle 1 equals the measure of angle 2. So algebraically, how would we represent the fact that the two angles are complementary? We could write down the equation, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So the measure of this angle plus the measure of this angle equals 90 degrees here. And now I can use substitution. You may already be seeing ahead to the answer, but I'm going to go through the algebra anyway. I can substitute either one of these for the other in this equation. So I'm going to substitute the measure of angle 1 in for the measure of angle 2, since the two are equal. So this equation becomes the measure of angle 1 plus another measure of angle 1 equals 90 degrees. And that turns into 2 times the measure of angle 1 equals 90 degrees. We can divide both sides of that equation by 2 so that the measure of angle 1 equals 45 degrees. Now the problem asked us to find their measures. We've only found one measure, but because the two angles are congruent, they both have the same measure. Just to be thorough, we can write the measure of angle 2 also equals 45 degrees. So I've used the two facts that I found in the problem statement, use those to make two equations, and then I use the substitution method to solve both equations and find all of the unknowns. You try this one. Angle A and angle B are supplementary. Measure of angle A is 2x, and the measure of angle B is x minus 15. Find the value of x.
I want wooden snowmen, but no one sells them. I'll be right out. I want wooden snowmen, but no one sells them. I'll be right out.
Vertical angles are angles such that the sides of one angle are opposite rays to the sides of the other angle. Let's try to make sense of that. Here's a side of this angle, And that ray is an opposite ray to this ray over here. Now the other side of this first angle, let's call it angle 1, is an opposite ray to the other side of angle 2. That's what it means for the sides of one angle and the sides of the other angle to be opposite rays. So when two lines intersect, they form two pairs of vertical angles. Angle 1 and angle 2 are a pair of vertical angles. And we also have another pair formed. Angle 3 and angle 4 are also a pair of vertical angles. Here's another definition for you. A theorem is a statement that can be proved using only postulates and fundamental geometrical ideas. So if you remember, a postulate is a statement that can't be proved. A theorem is a statement that can be proved. And one of the main things mathematicians are about is starting from initial postulates and fundamental ideas that we all accept and proving new theorems that allow us to prove even more theorems that allow us to figure things out. The vertical angle theorem says that vertical angles are congruent. In other words, this angle is congruent to this angle. I've labeled them differently in this diagram. Apologies for that. And this angle is congruent to this angle. Not all four angles are congruent. Only the green pair is congruent here, and the red pair is congruent here. You can actually prove this theorem using the angle addition postulate and some algebra. If you want to try that, you can check this section in your textbook for some hints. And another hint for you is to use variables like the measure of angle 1 and the measure of angle 2. Let's check out GeoGebra Tube, which I haven't shown you yet, but it's a cool application and you can actually download GeoGebra for free onto your computer if you want to play with it. I made a little app in GeoGebra Tube that I'm going to show you. Okay, here's a pair of vertical angles. And one thing that GeoGebra lets you do is if you construct something according to your guideline, in my case, I just constructed two lines that intersect at point B, you can actually drag around the different parts of your diagram and see what happens. So you can see from this demonstration that the measure of these two angles is equal no matter where I drag point A. Still equal now, still equal now. So GeoGebra is a way that you can prove conjectures to yourself. That's not a mathematically rigorous proof, but you can test your conjectures. If you think that something might be true, you can set up a GeoGebra applet and drag your points around and see what happens. Okay, here's another example problem. Let's find the measure of angle ZOT. This is the angle that we're looking for. We're given the information that ray OT bisects angle SOU. Okay, ray OT here bisects angle SOU. If this ray bisects this angle, that tells us that the two halves of this angle, SOU, must be congruent. So I'm going to mark those as congruent to each other. So we've used this piece of information. Now we're told that the measure of angle UOV is 35 degrees. That's been labeled for us on the diagram. The measure of angle YOW is 120, which has also been labeled for us on the diagram. So we still are not very far towards getting the measure of angle ZOT. We don't really have anything labeled inside here. So let's go ahead and use the vertical angle theorem to label what we can. This angle here, this 35-degree angle, is vertical angles with this angle over here. So I'm going to write 35 degrees on this angle. Now, the 120-degree angle is a vertical angle with this entire angle, which tells me that the big angle here is 120 degrees. Since I already know that this angle is bisected into two halves, that tells me that this half must be 60 degrees and this half must be 60 degrees. Now, am I any further towards getting the measure of angle ZOT? Yes, because I already know that this part of the angle is 60 degrees. What I'm still wondering is how to find this part of the angle. One fact that we have to look back in our notes to remember is that a linear triple, so this angle here, I'm gonna double mark these angles, and this angle here, triple mark, double mark, and single mark these three angles because they're all different. These three angles form a linear triple. And because of that, we know that their measures add up to 180 degrees. So that fact is going to allow us to find the measure of this angle. 120 plus this angle here, angle WOV, plus 35 equals 180. So I'm going to write that over here. 120 plus, let's call this x. X plus 35 equals 180. And you're comfortable enough with algebra to be able to solve that and figure out that x equals 45 degrees. Oops. Sorry, I wasn't comfortable enough with algebra to solve that. X equals 25 degrees. Okay, so if x equals 25 degrees, then this angle here is vertical angles with this angle over here, which we were wondering about in the first place. So I now know that this angle is 25 degrees, and I can add the measure of angle ZOS to the measure of SOT to get the entire angle ZOT, which is what I'm looking for. So I have 25 degrees plus 60 degrees is the measure of angle ZOT, and that equals 85 degrees. Now you try one. Use the diagram to answer the following questions. For further practice, see page 52 of your text, numbers 1, 3, 5, 13, 15, 17, and all the odds up to 27.